Okay, we are starting now with the storage section, and in this storage section, we will be covering some of the important topics on the AWS resources available for the storage. One thing I would also encourage you to just ignore that if some of the noises is coming up in the audio, maybe you could just ignore them and just listen to the things that I am saying. So here in this storage section, we are going to cover here the EBS and local instance store, EFS, Elastic File System, Amazon S3 for sure, and some of the solution architecture that we can build with S3, Amazon FSx, Amazon AWS Data Sync, and AWS Transfer Family. So here, these are the things we'll be covering in this section, and we will start here with Okay, now let us talk about the EBS volumes and EC2 instance store. So first, let's start with the EBS volumes. So EBS volumes are network drives, and you attach them to one instance at a time, and except with the EBS multi-attach feature that I will show you very soon. So they are linked to a specific availability zone, and if you wanted to transfer them between a different AZ, you need to first of all snapshot them and then restore them into that other availability zone. Your volumes can be resized, but only up like this, so you can increase the volume size. You can only increase the volume size without detaching the EBS volume first, and you need to make sure also to leverage the EBS volume as much as you can to enjoy the maximum throughputs. So as in the given in the diagram, here what it looks like, so we have EC2 instance, and we have an EBS volume attached to it, of like 10 gigabytes, and another EC2 instance that will have maybe 2 EBS volumes attached to it of 100 gigabytes and 50 gigabytes. So so here in one case we have just attached one EBS volume, and another we have attached 2 EBS volume. So this is what this diagram is showing up. Now for EBS volume types, so you have different types of volumes for EBS. You have GP2 or GP3 SST family. And G means general, so general purpose SST volumes that will balance a good price and performance and fits most of the workloads. But if you want extremely high performance, very high throughput, very low latency, then you need to look into the I family. So the IO1, IO2, and IO2 Block Express. So if you have a need for a low cost hard drive SSD, so that's going to be designed for frequently accessed and throughput intensive workload, usually sequential reads. Then SC1 is going to be the great choice. And if you want cold storage for less frequently accessed workloads, then SC1 is going to be the good use case for you. The EBS volume will have general characteristics, but they will be characterized in terms of throughputs and IOPS, which is IO operations per second. And when you are in doubt, of course, like always look for the AWS documentation in terms of boot volumes, which is where your operating system can be for your EC2 instance, and then it can be only GP2 or GP3 or IO1 or IO2. Okay, so now snapshots are very helpful to transfer EBS volume between availability zone, and they are incremental. So you only back up and changed blocks behind the scenes. Only changed block behind the scene will be backed up. Then the backups will use IO, and so that means that because the volumes going to be read by AWS, and if you are running an application that is also handling a lot of read traffic, and you are on top of doing your backup, then you may experience like a decreased performance. The snapshots are going to be stored in S3 in the backend, but you are not going to be here getting direct access to them, and it's not necessary for you to detach your volume to do a snapshot, but it's recommended, because if your volume is being actively used while you do a snapshot, you may get inconsistent data. Here you can copy a snapshot across availability zone, and yes, for sure, and you can restore a snapshots across AZ, across availability zone, of course, but you can also copy a snapshot across region for disaster recovery purposes. So it's a really good practice to a snapshot, for example, data in one region and then copy it to another region in case if you wanted to restore the data for the disaster recovery purposes. Now it's also possible for you to make Amazon machine images from your snapshots using the AMI feature, and this is very common. For example, if you bootstrap an application and then make an AMI out of it. Now, when you restore an EBS volume, especially large ones, then you need to pre-warm them. That means you need to read all the blocks to have the maximum performance. And to do so, you have two ways of doing it. The first one is using newer feature of AWS, because that was very popular request. It's called the fast snapshot restore, which is FSR for short, FSR feature. And the idea is that the feature is going to read your EBS snapshot entirely and then give it to you. This way, when you restore it, it's going to be pre-warmed. But if you want to do it the cold way, then you need to just attach this restored EBS volume to your EC2 instance, and then you would issue a command directly from within the EC2 instance, FIO or DD command directly from within the instance to read the entire volume. Now, when it comes to automating a snapshot, you can use, for example, the Amazon Data Lifecycle Manager to do the automatic snapshot. Now we will move on to the another feature of EBS Multiattach, and it's only available for the IO1 and IO2 family, only to the I family, okay, which goes against like what I told you earlier, but it gives you the ability to attach the same EBS volume to the multiple instances in the same availability zone, and each instance will have full read and write permission on the volume. So it's only for a specific kind of applications. For example, the ones that need higher application availability, for example, like Teradata that has native support for this feature, or application that must manage concurrent write operations for this very specific use case as well. Now the file system is a little bit different. It's not going to be XFS and or EX4 extension 4 and so on. It's going to be a file system that's cluster aware, and it's not the kind of things you deal with every day. So it's very unique feature for very unique use case, but you need to know that it exists. And so the architecture looks like, well, you have one, for example, IO2 volume with a multi-attach feature. IO2 volume, if you are not able to see, IO2 volume with multi-attach feature, and it can be attached to multiple EC2 instances at a time. Now, when you consider your local EC2 instance store, this one is not a network disk, it's a physical disk that is going to be attached to the physical server where your EC2 is. And while we do this, while you get a very high IOPS, you will get very high IOPS because, well, the disk is attached to your EC2 instance bus, or maybe you can consider the circuit. Okay. Now, what you get on the right hand side, for example, for the i3 family, i3.large to i3e and .metal, i3 family is a lot of write IOPS and a lot of read IOPS. And as you can see now, the disk can vary in size, and this is just indicating that they can obviously increase or retain, but the disk can go up to, for example, 7.5 terabytes. And if you strip them, so if you have them in parallel, you can reach, for example, 60 terabytes. And so 7.5 terabytes, 60 terabytes you are having in the parallel, and so you get a lot of IOPS, and it is still a block storage just like EBS, but it is a physical device, not a network device. It's a physical device directly attached to the instance, and it cannot be increased in size. And in case like your EC2 instance fail or get shut down, you will lose your data. That's what's the instance store. So you will lose your data because it is a physical disk attached to your EC2 instance. So if you compare EC2 instance store and EBS volumes, the instance store is physically attached to the machine. It is considered ephemeral storage, and usually considered as ephemeral storage considering in case of the Lambda, that's temp storage, ephemeral storage, where the EBS is a elastic bucket store, is a network drive, which is considered a persistent kind of a store. Persistent kind of a storage. Now the pros of using the EC2 instance store is that you get a better IO performance. So the EBS instance store is that you get a lot better IO performance. And so the EBS GP2, for example, will have max IOPS of around 16,000. IO1 will give you around 64,000, and IO2 block express is going to give you to 56,000. So, but we saw that the instance store can have IOPS in the millions. So now it's going to be very good if you want to have a buffer, a cache, a scratch data, or temporary content. Remember, it is ephemeral storage. And in case you reboot your EC2 instance, your data will not survive. But if you if you reboot your EC2 instance, your data will survive. But if you happen to stop or terminate your EC2 instance, then all the data on the EC2 instance store is going to be lost, and that means that you need to manage the data. So you need to back up that data automatically to make sure that if you want to keep it, you have a mechanism to do so. And because it is an EC2 instance store and it's a physical storage, you also cannot resize it. Whereas the EBS volume, of course, you could resize it. Okay, so this is it for this lecture, and I hope to see you in the next one.